Welcome to Chapter 5. We're going to combine sections 1 and 2. Our objective is to learn to solve an equation using a proportion. Our essential question is, how do I use the DIRT formula? Our vocabulary will be ratio, equivalent ratio, and proportion for the first half. Ratios can be written in several ways. You can use the word 2, 7 to 5. You can use a colon and also read it 7 to 5. And you can use a fraction and read it 7 to 5. We want to find two ratios that are equivalent to each given ratio. We have the fraction 9/27 or the ratio 9/27. Think of it as simplifying fractions or increasing the fractions. We can't always simplify, and if we need more than one solution, we may not have room to do that by simplifying. So one thing we could do is to multiply by the same value to both parts. 18/54 would be considered equivalent to 9/27. It's possible that we could divide and get 1/3 if we divided both by 9. We could do the same thing for 64/24 and multiply by 2. We could divide by 8. If you're in a situation where it's a simplified fraction, you may have to multiply by 2, by 3, by 4. You may have to choose different numbers. But no matter what, you multiply or divide the numerator and denominator by the same value. A proportion is an equation that states that two ratios are equivalent. Ratios that are equivalent are said to be proportional. Equivalent ratios are identical when they are written in simplest form. Below what you see is a proportion. 18/54 is equal to 9/27. It's called a proportion because both of them are equal to the fraction of 1/3. Now we want to simplify to tell whether the ratios form a proportion. So we have the ratio of 3/27 and 2/18. Our goal is to see if those are equivalent to the same simplified ratio. So let's simplify 3/27 by dividing by 3. We get 1/9. If we take 2/18 divided by 2, we get 1/9. Therefore, because they both equal the same simplified ratio, they are a proportion. Let's try the same thing with 12/15 and 27/36. We can divide 12 and 15 by 3 to get 4/5. 27 and 36 divide by 9 to get 3/4. It's important to remember to simplify as far as possible. And when we compare 4/5 and 3/4, they are not in proportion. There's a second way to check this. Cross products. Cross products can tell us whether ratios form a proportion. To check cross products, we check their diagonals by multiplying. So we would multiply 3 times 18, which equals 54. We would multiply 27 by 2, which equals 54. So because the cross products both equaled 54, we would say that they are in a proportion. If we check 12/15 and 27/36, we multiply 12 times 36, we get 432. We multiply 15 by 27, we get 405. So just like we found out when we simplified the ratios, if we use cross products, they also show us that they do not come out equal, so these are not a proportion. A lot of people prefer to use cross products because we like to multiply, and sometimes we prefer that over simplifying. It may be easier because we don't have to worry about reducing as far as possible. But you can choose to use either method. We will be using cross products a lot in upcoming lessons to solve problems. Moving to the second part, rate, and unit price are our key terms. A rate is a comparison of two quantities that have different units. A ratio, as we saw in the first half, 90/3, a rate would be 90 miles over 3 hours. The difference being that rates have different units that are being compared. Ratios are either comparing the same units or just comparing numbers. Unit rates are rates in which the second quantity is 1. So on the left-hand side you see rates, and on the right-hand side you see unit rates. 60 miles per 3 hours as a unit rate is 20 miles per 1 hour. 40 words per 2 minutes as a unit rate is 20 words per 1 minute. So if we want to find a unit rate, we're trying to get the denominator to be 1. Jeff can type 30 words in half a minute. How many words can he type in 1 minute? 30 words compared to 1/2 minute. We would need to multiply that by 2 to turn that into 1 minute in the denominator, and so Jeff can type 60 words in 1 minute. Penelope can type 90 words in 2 minutes. How many words can she type in 1 minute? Now we have 90 words per 2 minutes as a rate. We want that to be a unit rate, so we divide by 2. And Penelope can type 45 words per 1 minute. Unit price is a unit rate used to compare price per item. So the difference with the unit price is it's using money. In unit price, we always deal with the price in the numerator. You can see the label that's shown here is like one that you can see in a store. The cost of $6.44 is for the whole item. The 16.1 cents per ounce is its unit price. So if you were to compare the sizes and the values of different items, you would look at their price per ounce, or per pound, or whatever the unit might be. Let's compare these two types of Quaker Instant Oatmeal and Quaker Oatmeal. The cost of the Quaker Instant Maple and Brown Sugar is $4.89, and you get 10 servings. The cost of the other Quaker Oats is $3.29, and you get 30 servings. If you're looking for the value, the choice seems fairly obvious. But if we look at it as a comparison, let's truly see what the unit rate could be. Unit price means that we would divide both of these by the number of servings to get the price per ounce. So we could do that. So we could start by taking $4.89 divided by 10, and that would give us about 49 cents per serving. If we took $3.29 divided by 30, it would give us about 10 cents, or excuse me, about 11 cents per serving. So which one's cheaper? Obviously the 11 cents. You could think about this a second way. Oops, excuse me. If we're just simply trying to find the best deal, we want to compare the number of servings. You're probably not going to do that in your head by dividing by 30 in the store. You could take out a calculator, or you could use some estimation. Because this is 30 servings and this is 10, if we multiply 10 by 3, we get 30, and if we multiply $4.89 by 3, we know it's going to be $12 or more. And so we obviously can tell that that's a higher cost. If we find the exact cost, it would be $14.67 for 30 servings of the maple and brown sugar compared to $3.29 for the regular. Let's look at another unit price. Golf balls can be purchased in a 3-pack for $4.95 or a 12-pack for $18.95. Which is the better buy? So assuming you don't care how many golf balls you buy, maybe you're looking to buy 3, maybe you're looking to buy 12, maybe you're going to decide that you're going to buy 12, but maybe you'll buy them in the 3-packs instead of all at once. Regardless of all that information, we want to know what the price per golf ball is. So we set these up as rates to begin with of the price of the package divided by the number of golf balls you get. So in the first 3-pack, we get $4.95 will get us 3 golf balls. Dividing that, it's $1.65 per golf ball. If we check the 12-pack, we take the price, $18.95 divided by 12, and it would cost us. So if we're comparing, we could also look at this a second way. If we were to multiply the first fraction by 4, we would see that it would cost us $19.80 for 12 golf balls, which is more than it cost with the 12-pack. So no matter which way you look at it, as long as you're comparing the same unit in the denominator, you can compare the prices. But unit price always works by by dividing it down to 1 so that you know you have an equal comparison. So either way that we look at it, the 12-pack would be our better deal. Last topic is the formula for rate equals distance divided by time. That's what the R equals D over T, or as we saw it in the original objective and essential question, D equals R times T. It's called the DIRT formula because it makes it easy for us to remember. So if D stands for distance, R stands for rate, T stands for time. When we set these up, we're looking at distance, rate, and time. So as we read through a problem, it took Marcus half an hour to drive home from work. He averaged 34 miles per hour. How far does Marcus live from his work? So what that tells me is that it took Marcus half an hour. Okay, we need to decide if we're looking at hours, if we're looking at minutes. So if it took Marcus 1/2 hour, his time would have been half. Now normally we would say 30 minutes, but look at our rate. Our rate is measured as 34 miles per hour. So rate, 35 miles per hour. So we want to know the distance. So D equals 34 times the time, which is half. So we multiply those together, and D would equal 17. So 17 needs a label. Because it was miles per hour, our distance would be measured in miles. Let's check out another problem and see how it looks. Roberto will be driving from Los Angeles to Las Vegas tomorrow. He can average 60 miles per hour for the trip. It is 282 miles from Los Angeles to Las Vegas. How long will it take Roberto to drive from Los Angeles to Las Vegas? So now we know the distance is 282 miles. We know his rate is 60 miles per hour. And your rate is always going to be 2 units. Miles per hour, kilometers per minute, whatever it may be. And we're looking for the time. So the distance equals the rate, 60, times t. Good thing we have those solving equation skills. We know we have to divide by 60. So 282 divided by 60 gives you a time of 4.7. And our label again, we look back to the problem, would be hours because that's the unit we were using in the rate. Okay, let's check one more. It takes 2 hours for a turtle to move a distance of 60 meters. How fast in meters per hour is the turtle moving? So the time is 2 hours. The distance is 60 meters. Now we are looking for the rate. So distance equals 60. Rate is R times 2. Again, our skills that we got from the algebra we've done is divide by 2. 30 equals R. So that means our rate would be 30, and we take our 2 units that we have here, miles per hour. Make sure you've written down the DIRT formula so that you have it to reference, and that D is distance, R is rate, T is time. Make sure your notes are filled out completely. Come up with some questions that would be good quiz questions, or any questions that you still have that need to be answered. Review your notes and make sure before you get to class that you've gone back to do the summary.